My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Operation Research as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define operations research. Answer. Operations research, or, is a subject that uses mathematics, logic, and data to help people make better decisions in business, management, and daily life. It finds the best possible solution to a problem, like reducing cost, increasing profit, or saving time. Or started during World War II, when scientists helped the army plan the best use of resources like planes, fuel, and soldiers. After the war, these techniques were used in industries, transport, hospitals, and business planning. Example: a delivery company wants to send parcels to 5 cities using the least fuel and shortest route. Or helps the company choose the best path, saving both time and money. Easy tip to remember. Or is equal to optimum result. It helps you choose the best result using limited resources. Conclusion: operations research is like a math-based problem solver that helps managers and companies take smart, data-driven decisions. Next important short question is: 2. What is linear and nonlinear programming? Answer. Linear programming, LP, is a method used to solve problems where the goal, like maximum profit or minimum cost, and all conditions are written using linear, straight-line equations. Example: a factory makes chairs and tables. It uses LP to decide how many of each to produce to earn maximum profit using limited wood and labor. All relationships, profit, time, etc., are straight-line or constant rate. Nonlinear programming, NLP, is used when the goal or conditions include curved, nonlinear equations. These problems are more complex and realistic, especially when outputs don't increase evenly. Example: a company wants to price a new product. The profit doesn't rise in a straight line, it changes in a curve. NLP helps find the best price. Easy tip to remember. Linear is equal to straight and simple. Nonlinear is equal to curved and complex. Conclusion: use linear programming for simple, straight problems and nonlinear programming for complex, real-life situations. Next important short question is: 3. What is integer programming? Answer. Integer programming, IP, is a type of problem-solving method in operations research where the solution must be in whole numbers, integers, not fractions or decimals. It is similar to linear programming but with one difference. Some or all of the variables must be integers, like 1, 2, 3, not 1.5 or 2.8. Example: a school wants to buy buses and vans for transport. It can't buy half a bus, so the number of vehicles must be in whole numbers. Integer programming helps the school decide how many buses and vans to buy to minimize cost. Types of integer programming: 1. Pure IP, all variables are integers. 2. Mixed IP, some variables are integers. 3. 0-1 IP, variables are only 0 or 1, yes, no problems. Easy tip to remember. Integer is equal to whole numbers only. Conclusion: integer programming is useful when dealing with items that can't be divided, like people, machines, or vehicles. Next important short question is: 4. What is linear programming? Answer. Linear programming, LP, is a mathematical method used to find the best result, like maximum profit or minimum cost, when there are limited resources, such as time, money, or materials. In ALP, both the goal, objective function, and conditions, constraints, must be written as linear equations, straight line form. Example: a company makes pens and pencils. It has limited ink and plastic. Using ALP, it can decide how many pens and pencils to make to earn maximum profit without crossing resource limits. Key parts of ALP: objective function, what to maximize, minimize. Constraints, the limitations, like budget, time, space. Non-negative variables, you can't make negative products. Easy tip to remember: linear is equal to straight equations. Programming is equal to planning the best way. Conclusion: linear programming is a simple and powerful tool used in business, transport, and manufacturing to plan the best use of limited resources. Next important short question is: 5. What are the assumptions behind linear programming problem, LPP? Answer: linear programming problem, LPP, is based on some important assumptions that must be true to get the correct solution. Main assumptions of LPP: 1. Linearity. The relationship between variables is linear, straight line. Example: profit is equal to 5x plus 3y. 2. Additivity. The total effect is the sum of individual effects. Example: total resources used is equal to x plus y. 3. Non-negativity. Variables cannot be negative. You can't make 5 products. 4. Certainty. All values, profit, cost, time, etc., are known and fixed. No surprises or changes later. 5. Divisibility. Items can be divided into fractions. You can make 2.5 units, not valid for all problems. Example: a company planning production assumes exact values and linear equations to apply LPE. Easy tip to remember: LPE works best in a perfect world where everything is clear, fixed, and measurable. Next, Unit 1. Long questions. First important long question is: 1. Discuss operations, research, nature and origin. Answer: Introduction to Operations Research, or Operations Research, or is a scientific and systematic method of solving business and management problems using mathematics, statistics, and logic. It helps in making better decisions by analyzing situations and choosing the best option. Origin of Operations Research. Operations research began during World War II. In 1939, British scientists were asked to help the military use limited resources, like aircraft, radar, and ships, more effectively. These scientists studied real problems, collected data, and used mathematical models to guide decision-making. Their success in war planning led to the growth of ore in industries, transport, hospitals, and government after the war. Example: ore helped decide how many aircraft should be sent on a mission to maximize damage and minimize loss. Nature, characteristics of operations research. 1. Scientific approach. Ore follows a step-by-step scientific process, defining a problem, creating a model, solving it, and checking results. 2. Quantitative analysis. Ore uses numbers, data, and equations to understand and solve problems. 3. Optimization focus. The goal is to get the best outcome, like maximum profit or minimum cost. 4. Team approach. Ore problems are solved by a team of experts from different fields, engineers, mathematicians, managers, etc. 5. System orientation. Ore looks at the entire system, not just one part, to find the best overall solution. 6. Decision-making tool. OR supports managers and decision-makers by giving them logical and data-based options. Easy tip to remember. OR is equal to organized reasoning using logic and maths to make better decisions. Conclusion. Operations research started in war but is now used in business, transport, healthcare, supply chains, and many more areas. Its nature is logical, data-driven, and problem-solving focused. OR is like a math helper for smart decision-making. Next important long question is: to explain managerial applications and limitations of operations research. Introduction. Operations research, OR, helps managers make better decisions using mathematical and logical methods. It is like a scientific tool that helps in solving real business problems by finding the best possible solution. Managerial applications of operations research. 1. Production management. OR helps decide how much to produce, what resources to use, and how to reduce waste. Example: a factory uses OR to plan daily production and minimize raw material cost. 2. Inventory control. OR helps maintain the right amount of stock, not too much, not too little. Example: a shop uses OR to reorder goods at the right time. 3. Transportation and logistics. OR is used to find the shortest route, save fuel, and reduce delivery time. Example: a courier company uses OR to plan delivery routes. 4. Project planning. Tools like PERT and CPM help managers plan tasks and reduce project delays. 5. Finance and budgeting. OR helps in making investment decisions, budgeting, and cost control. 6. Human resource planning. OR helps in deciding how many staff are needed and how to allocate duties. Limitations of operations research. 1. Depends on accurate data. If the input data is wrong or incomplete, the result will also be wrong. 2. Complex for small problems. For small, simple problems, using OR may be unnecessary and time-consuming. 3. Cannot handle human emotions. OR only deals with logic and numbers. It can't understand employee feelings or motivation. 4. High cost and time. OR models may require advanced software, skilled people, and time to implement. 5. Assumes ideal conditions. Many OR techniques assume fixed and known conditions, which may not match real life. Easy tip to remember. OR is equal to optimizing results, but not emotions. Conclusion. OR is a powerful tool for managers to make smart decisions in areas like production, transport, and planning. But it has limitations when it comes to real-world changes, emotions, and human behavior. Next important long question is: 3. What is goal programming? State clearly its assumptions. What is goal programming? Goal programming is an extension of linear programming, used when a business or organization has more than one goal to achieve at the same time. It helps to find a solution that balances multiple goals, even if not all of them can be achieved perfectly. Unlike linear programming, which focuses on just one objective, like maximizing profit, goal programming allows decision-makers to work with many objectives, like reducing cost, increasing customer satisfaction, and reducing delivery time altogether. Example: a delivery company wants to 1. Minimize fuel cost. 2. Maximize customer satisfaction. 3. Reduce delivery time. All three goals are important, but maybe they can't reduce fuel cost and delivery time at the same time. Goal programming helps find the best possible balance between these goals. Assumptions of goal programming. 1. Multiple goals are known. All the goals should be clearly defined and measurable. 2. Goals can be ranked or weighted. Some goals may be more important than others. We can assign priority levels to each. 3. Linearity. The relationships between variables and goals should be linear, like in linear programming. 4. Deviation variables. Positive or negative deviations, i.e., how much we miss a goal, can be calculated and minimized. 5. No perfect solution always. It accepts that not all goals can be fully achieved. It looks for the closest best solution. 6. Certainty. All data like resource availability, costs, and demand are assumed to be known and constant. Easy tip to remember. Goal programming is equal to many goals, one best compromise. Conclusion. Goal programming is useful in real-life decision-making, where businesses have to manage several goals at once. It provides a practical solution that satisfies the most important goals as much as possible within given resources and conditions. Next important long question is: 4. What is dynamic programming? Explain it in detail. What is dynamic programming? Dynamic programming, DP, is a problem-solving method used when a big problem can be broken into smaller subproblems, and these subproblems are solved step by step to get the final best solution. It is used when decisions need to be made in stages, and each decision affects the next stage. DP stores the results of smaller problems and reuses them, which saves time and effort. Key idea: solve small problems first, remember their answers, and use them to solve bigger problems. Example: imagine a traveler wants to visit 5 cities in the shortest route possible, known as the traveling salesman problem. Instead of checking all possible paths, which takes a lot of time, dynamic programming breaks the problem into smaller paths and finds the shortest combinations step by step. Steps in dynamic programming. 1. Divide the problem into stages. Each stage represents a decision point. 2. Find subproblems. Identify smaller problems that are part of the big problem. 3. Solve each subproblem once. Store the answer to avoid solving it again, called memoization. 4. Use the stored answers. Combine them to get the final solution. Applications in business. Inventory management, how much to order each month. Resource allocation. Project scheduling. Investment planning. Advantages. Saves time by avoiding repetition. Gives accurate results. Useful in complex, multi-step problems. Easy tip to remember. Dynamic programming is equal to divide and remember. Break the problem, solve parts, remember answers, combine them. Conclusion. Dynamic programming is a smart way to solve complex problems in steps, especially when one decision affects the next. It's widely used in business planning, logistics, and computer programming to find the most efficient and cost-effective solutions. Next important long question is: 5. What is LPP? Write the mathematical formulation of LPE. What is LPP? LPP, linear programming problem, is a mathematical technique used to find the best possible result, like maximum profit or minimum cost, when there are limited resources like time, money, or materials. In LPP, we use linear equations to represent the problem. It is widely used in business, industry, transportation, and agriculture to make smart decisions. Real-life example. A bakery makes cakes and cookies. They want to maximize profit, but they have limited flour and labor. LPP helps them decide how many cakes and cookies to make for maximum profit without crossing the limits. Mathematical formulation of LPP. Let x1, x2, xn is equal to decision variables, like number of items to produce. 1. Objective function. This is the goal, either maximize profit or minimize cost. Example. Maximize z is equal to c1x1 plus c2x2 plus cnxn. 2. Constraints. These are the limits or restrictions, like material, money, or time. Example. 3. Non-negativity condition. Variables cannot be negative. x1, x2, xn greater than or equal to 0. Easy tip to remember. LPP is equal to least problem planning. Helps plan the best way with limited resources. Conclusion. LPP is a powerful decision-making tool that uses linear math models to solve problems in production, budgeting, and logistics. It helps organizations make the most profit or save the most cost within available resources. Next important long question is: 6. Solve the following LPP using graphical method. x1 greater than or equal to 0, x2 greater than or equal to 0. Q. Solve the following LPP using graphical method. Minimize z is equal to x greater than or equal to 0, x greater than or equal to 0. Step-by-step solution, simple explanation. This is a linear programming problem where we want to minimize cost using the graphical method. Step 1. Convert inequalities to equations. We will plot the constraint lines by treating the inequalities as equalities. 1. 6x plus 2x is equal to 8. 2. 2x plus 4x is equal to 12. 3. 4x plus 1 2x is equal to 24. Step 2. Find intercepts for each line. Line 1, 6x plus 2x is equal to 8. Put x is equal to 0, 2x is equal to 8, x is equal to 4. Put x is equal to 0, 6x is equal to 8, x is equal to 1.33. Line 2, 2x plus 4x is equal to 12. Put x is equal to 0, 4x is equal to 12, x is equal to 3. Put x is equal to 0, 2x is equal to 12, x is equal to 6. Line 3, 4x plus 1 2x is equal to 24. Put x is equal to 0, 1 2x is equal to 24, x is equal to 2. Put x is equal to 0, 4x is equal to 24, x is equal to 6. Step 3. Plot the lines on a graph. Draw the lines using the points above on the x plane. Shade the feasible region that satisfies all constraints, region common to all inequalities and in first quadrant only, i.e., x greater than or equal to 0, x greater than or equal to 0. Since all inequalities are greater than or equal to, the feasible region will be above or to the right of the lines. Step 4. Find corner points, vertices, of the feasible region. We now find the intersection points of the lines by solving them in pairs. I. Intersection of line 1 and 2. 6x plus 2x is equal to 8. 2x plus 4x is equal to 12. Solve using substitution or elimination. Multiply second equation by 3. 6x plus 1 2x is equal to 36. Now subtract the first equation. 6x plus 1 2x, 6x plus 2x, is equal to 36 to 8. 10x is equal to 28, x is equal to 2.8. Substitute in first equation. 6x plus 2, 2.8, is equal to 8. 6x plus 5.6 is equal to 8. 6x is equal to 2.4, x is equal to 0.4. So, point A is equal to 0.4, 2.8. Step 5. calculate Z at all corner points. Z is equal to 2000x plus 1500x. Heavy check mark at 0.4 to 0.8. Z is equal to 2000, 0.4 plus 1500 to 0.8 is equal to 800 plus 4200 is equal to 5000 rupees. Check other corner points if needed, if any lie in the feasible region from graph. Step 6. Choose the minimum Z. From calculation, Z is minimum at point 0.4 to 0.8. Final answer. Minimum cost Z is equal to 5000 rupees at X is equal to 0.4 and X is equal to 2.8. Easy tip to remember. Use IGC method for graphical LPPs. I intercepts, G graph, C corner point calculations. Next important long question is 7. Discuss the exceptional special cases in linear programming by graphical method, problem-based. Introduction. In linear programming, when we solve problems using the graphical method, most of the time we get a unique optimal solution, like maximum profit or minimum cost at a single corner point. But sometimes, special or exceptional cases occur. These situations are important and often asked in exams. 1. Multiple optimal solutions, more than one best answer. This happens when the objective function line is parallel to a constraint line that passes through the feasible region. The optimal value, Z, remains the same on more than one point. Example. Maximize Z is equal to 3x plus 2y. Subject to x plus y less than or equal to 4. 2x plus 2y less than or equal to 8. X, y greater than or equal to 0. Here, the objective function is parallel to the constraint, so the Z value is same on multiple points. Tip: if you get Z value same at two adjacent corner points, then infinite solutions lie on the line between them. 2. Unbounded solution, no limit to maximum minimum. This occurs when the feasible region is open, not closed, in the direction where the objective function is increasing or decreasing. The value of Z can go on increasing or decreasing without limit. Example. Maximize Z is equal to x plus y. Subject to x, y greater than or equal to 2. X, y greater than or equal to 0. The feasible region is unbounded, open-ended, and Z has no maximum value. Tip: if the region is going on and on in one direction, check if Z also increases infinitely, that's an unbounded solution. 3. Infeasible solution, no solution possible. Happens when no common area, feasible region, is found that satisfies all the constraints. Graphically, lines do not intersect in the first quadrant or have no overlapping area. Example. X plus y less than or equal to 2. X plus y greater than or equal to 5. X, y greater than or equal to 0. These two inequalities do not overlap, so no solution exists. Tip: if no area is common to all constraints, the problem is infeasible. Easy way to remember. Use the code MUI for special cases. M. Multiple solutions. U. Unbounded solution. I. Infeasible solution. Conclusion. Special cases in linear programming show that not all problems have one clear answer. Knowing how to identify multiple, unbounded, or infeasible cases makes your graph-based LPE answers stronger and exam-ready.